humanity, by convictions of the James Webb Space Telescope, could need to reconsider an enthralling revelation. The telescope has uncovered an enthralling spine chiller in Proxima Andromeda, the closest Titanic star development to us. Amidst Proxima Andromeda, the closest star structure stands isolated, with odd fake lighting leaving the sharp drive locale enchanted. Should this be the far-reaching expected solicitation of untouchable life past our planetary structure? How do specialists pick whether those lights propose the presence of sharp life on Proxima b? As we plunge into how the James Webb Space Telescope, JWST, has seen what might be city lights 7 trillion miles from Earth, clearly, interest in the universe's striking snippets of data remains massive. Mechanical moves have pushed our ability to research Earth and the sky, influencing us to look at the immense levels of the universe. Earth remains the primary planet known to hold life. Additionally, the well-established question gets passed: are we uncovering the presence of extraterrestrial life, or are their principles simply bits of the grandiose establishment? In 1984, two American space specialists, Jill Tarter and Thomas Pearson, began an endeavor called the Pursuit for Extraterrestrial Knowledge. Said this magnanimous undertaking wants to channel through gigantic space radio transmissions. As these signs travel gigantic distances, additionally, they are the fundamental tech procedure for looking for extraterrestrial modern correspondence. The 42 radio telescopes put in the Californian lower regions were exactly tuned to the universe's frequencies. These telescopes, known as the Allen Telescope Group, were ordinary to see any unconventional signs from space, not persisting through sweeping seeing. No persuading check as to extraterrestrial human action has been seen. Industrious updates from NASA propose that the James Webb Space Telescope, JWST, could have likewise seen fake city lights from interfacing planets. This raises the issue of whether the JWST could indeed be mankind's great leap forward in taking a gander at the universe. The JWST is the most phenomenal instrument in mankind's arrangement of encounters for understanding the universe. Coordinated around 1 million miles from Earth, this colossal telescope fills in as our window to the earliest records of the universe, giving clearer pieces of insight into the movement of structures, stars, and planets. Coordinated with cutting-edge cameras and channels, the JWST engages cosmologists to research the huge degree of unconventionalities by investigating specific light frequencies. The JWST analyzes exoplanets for indications of something happening where it counts. Besides its unequaled ability to peer past ordinary hack points, it has incited faltering revelations. For instance, the JWST has seen a greater number of universes than previously known, revealing a more critical perception of the universe's coalition and development. As mankind pushes to research the farthest levels of space, the JWST hopes to be a critical part in uncovering the advantaged mysteries of far-off universes. The divulgence of more than 4,000 exoplanets circumnavigating distant stars shows the stunning development in our mission to understand the universe. Red dwarf stars, being more subtle and cooler than our sun, present prime opportunities for thinking about the possible tenability for life. The TRAPPIST-1 system, with its 7 Earth-sized planets, incorporates 3 within the star's descent zone, where conditions could uphold liquid water despite its cooler temperatures. TRAPPIST-1 conveys a tricky, Earth-like light, proposing its planets could hold life. Additionally, Proxima Centauri, the closest huge star to our planetary system, is a faintly glowing star, and any planet circumnavigating it would be closer than Earth to the Sun. However, its planets may not stay mindful of conditions strong for life. The assessment of exoplanets has opened a huge expansiveness of potential exposures, revealing interesting planetary structures past our own. Red dwarf stars, being the most broadly perceived type in the universe, offer fortifying possible opportunities for tracking down sensible planets. In spite of their cooler temperatures, the TRAPPIST-1 system, with its location and water vapor presence, highlights the potential for life-supporting conditions. The JWST, with its high-level instruments, continues to change our understanding by taking discrete exoplanet conditions and recognizing key particles connected with natural development. As specialists analyze outrageous circumstances on Earth, like those expected by extremophiles, they gain insights into the potential for life in awful conditions elsewhere in the universe. The assessment of outrageous conditions fosters our cognizance of life's adaptability and grows the quest for extraterrestrial life, whether microbial life on a far-off world or advanced human civilizations. Each discovery carries us closer to responding to one of mankind's most basic requests. Are we alone in the universe? As imaginative types of progress like the JWST drive our capacity to explore further into the universe, the mission for life beyond Earth continues to be, quite possibly, one of the most spellbinding endeavors in science. The JWST, outfitted with top-level instruments, adds to revealing the universe's insider mysteries and shedding light on the potential for life beyond our planetary system. The mission for extraterrestrial life is potentially one of humankind's most critical and exciting endeavors. As mechanical progressions stretch the limits of what is possible, the James Webb Space Telescope, JWST, remains at the very front of this work. Its cutting-edge instruments and extraordinary limits grant analysts to investigate faraway exoplanets and their environmental factors in ways already hard to come to. The JWST's capacity to perceive and explore climatic designs gives critical insights into the potential for life-supporting circumstances on exoplanets. By searching for the presence of key particles like water vapor, carbon dioxide, and oxygen, specialists can evaluate the likelihood of reasonable conditions. This is especially critical in the journey for planets that could have conditions like Earth, where life as we comprehend it could truly prosper. In addition to the fact that it analyzes Earth-like planets, but the JWST also centers around additional outrageous circumstances, counting those around red small stars. These stars, while cooler and dimmer than our Sun, are the most common type in the system and frequently have planets within their bearable zones. The TRAPPIST-1 system, with its 7 Earth-sized planets, is an ideal example of an objective for such assessments. Notwithstanding the cooler temperatures of TRAPPIST-1, its planet's closeness to the star and the presence of water vapor suggest that these worlds could support life. The investigation of extremophiles on Earth, animals that thrive in outrageous conditions, gives valuable insights into the kinds of conditions where life could exist elsewhere. Extremophiles, which can make do in outrageous temperatures, acidic circumstances, or high radiation levels, challenge our comprehension of life's cutoff points and expand the scope of potential circumstances past Earth. As our technology advances, furthermore, how we might interpret the universe grows. The quest for extraterrestrial life continues to evolve. The JWST, with its cutting-edge technology and capacity to look into the far-off universe, represents a critical leap forward in our exploration endeavors. Each new discovery, whether it be a far-off exoplanet or a novel extremophile, adds to the growing mosaic of how we decipher the universe and our place within it. The investigation of exoplanets and outrageous circumstances not only aims to answer the central inquiry of whether we are separated from everyone else but also enhances our comprehension of the conditions necessary for life. The insights gained from the JWST and other great advances will shape how we might interpret the universe and guide future missions in the quest for life beyond Earth. Taking into account everything, the search for extraterrestrial life is a dynamic and developing field driven by advances in innovation and our interminable interest about the universe. The James Webb Space Telescope, with its astounding capacities, assumes a huge part in this attempt, offering new perspectives and possibilities as we proceed to investigate the immensity of space. Each discovery carries us closer to disentangling the secrets of the universe and grasping our spot in the grand plan. As we set up the James Webb Space Telescope, JWST is set to be a fundamental instrument in the continuous journey to look for extraterrestrial life and expand how we might interpret the universe. The telescope's capacity to explore the states of exoplanets with astonishing nuance could lead to pivotal discoveries by distinguishing biomarkers, indications of something happening where it counts, for example, explicit gases or synthetic examples. Specialists desire to identify planets where life could exist or may have existed in the past. Future missions and advancements in innovation will probably expand upon the foundation laid by the JWST. New telescopes and space missions are expected to further refine our search for habitable universes and perhaps life-supporting circumstances. For example, the cutting-edge space observatories could have advanced instruments capable of recognizing fainter signals and considering exoplanets at greater distances. These advancements will improve our ability to search for life across a broader range of conditions. the investigation of exoplanets in the habitable zones of stars, especially around red dwarf stars, remains a priority. These stars offer a unique opportunity to study planets that could have conditions like Earth's, despite being cooler and less brilliant than our Sun. The TRAPPIST-1 system, with its intriguing cluster of Earth-sized planets, continues to be a focal point for astronomers contemplating possible livability and life-supporting conditions. In accordance with space-based perceptions, missions to different parts of our nearby planetary group, like Mars or the icy moons of Jupiter and Saturn, will also play a significant role in the quest for life. Disclosures made in our own planetary system, like potential biomarkers on moons or subsurface seas on moons like Europa and Enceladus, could provide significant insights about the presence of life beyond Earth and inform our quest strategies for far-off exoplanets. The integration of data from the JWST with ground-based perceptions, furthermore other space missions, will offer a more far-reaching picture of the universe. Cooperative endeavors among global space associations, research establishments, and the scholar community will be fundamental in deciphering revelations and developing new examination pathways. The cooperative energy between different observational stages will help address the most significant inquiries mankind has ever asked. Are we alone, or is life abundant somewhere else in the universe? Through these advances, we are just beginning to understand the full extent of our universe and its potential for life. The search for extraterrestrial life remains one of the most significant and exciting areas of scientific inquiry, with the JWST leading the way in our mission to find our infinite neighbors. As we continue to venture further into the immeasurability of space, the James Webb Space Telescope stands as a testament to human curiosity, desire, and the undaunted mission for knowledge. Its capacity to capture exceptional detail from far-off worlds, exoplanets, and stars is not only revolutionizing our understanding of the universe, but also stretching the boundaries of what we thought was possible in cosmic exploration. One of the principal benefits of the JWST is its capacity to study exoplanet environments exhaustively. Utilizing its infrared capacities, the telescope can recognize compound marks of gases that may indicate organic cycles, such as oxygen, methane, and carbon dioxide, key parts of Earth's biosphere. By noticing far-off planets in the habitable zones of stars, cosmologists hope to identify planets that could potentially support life, or at least the conditions necessary for life as we know it. This makes the JWST a significant tool in the search for extraterrestrial life. Besides, the investigation of exoplanets isn't solely centered on finding Earth-like worlds. The assortment of exoplanets that have been found, ranging from gas giants to rocky planets with outrageous temperatures, challenges our understanding of planetary arrangement and the potential for life in unanticipated conditions. By looking at the atmospheres of these worlds, researchers can better understand the conditions under which life might arise and adapt in ways we may not have previously imagined.